All right, let's get this review started. Who has questions?
Well,
I'd really like to do some more context free pumping on the, but I'll go to the over.
So I don't, was context free is not on the if, just the regular pumping limit.
I think that's
Is
just,
that different from what was in the study guide for some reason?
No, that is consistent.
I do have an extra review for exam 3 that I can help people when the time comes for them. Because I feel like, especially in a limited exam setting, it's very hard to pick good context-free pumping limit questions because most of them split into so many cases that it's very difficult to.
Here's some other pumping limit questions. 6G from homework 3. It's WR, WW, WR. Such that W is in the star closure of A.
Okay.
I hear that right? Yeah. It's my understanding that if I just pick a W that has at least M states in it, I win no matter what, right? Because I would be only screwing up that first WR.
So this seems context-free, right? This is not regular.
It's prove that it's not regular.
Prove that this is not regular.
Yeah.
Interesting. So if we're going to do that, what do we want to use as a string? What makes sense here?
I was just thinking W.
There should be no W in terms of the string that you pick, should be A's and B's.
Oh. They have divided by 2. You have divided by 2. Or start by, can you just pick A to the M?
You could.
A to the M.
Yeah.
A to the M 4 times.
So if we did A to the M, B to the M as WR, then W is B to the M, A to the M. W again is B to the M, A to the M, and WR is A to the M, B to the M. That's a heck of a string to pick, but since we have M characters, this seems like it's going to work in terms of regularity because we can only pick from those first A's with regards to creating a loop in some sense. So somehow we are going to devise some kind of DFA, and this happens in general, that we get to some kind of loop, and then we get to some kind of final state. And getting to that loop and iterating that loop for the first time has to happen within the first M characters, meaning it happens within these first A's. And you can, from here intuitively, see that if we make any change to this M, bumping it up or bumping it down, there's no way that the resulting string to this is in this language. We've made changes to these A's such that when we compare this W, the issue is that we have to be able to prove that there is no such W. It's not that it's the same W, it's that for any possible WR in here, that does not exist. An adequate intuitive argument is just saying that this WR has to map to some WR that is at the end. And so I would pick comparing these M's to these M's that are not changing. And saying if we make a change to here, which would represent this would become, looks like a great smiley face, regular pumping lemma smiley face. A to the M plus the length of Y for choosing I equals 2. And then the rest of the string, A to the M, B to the M. And by adding A's, if this was in this form before, any change we make to this has to also be made to that. So because we make this change and we don't make that change, then the resulting string is not in this language. And that would be an intuitive enough argument for an exam. You wouldn't have to go into too much more detail than this, except to make sure that all your ducks are in a row with regards to representing the problem, such as let L be a regular language. Let L be this, assume L is regular. Then there exists a DFA for it such that write the constraints. After you've written the constraints, say, so this tells us that getting to a loop and iterating the loop has to happen in the first m characters, which means that if we pick an I greater than 1, then we're going to be adding at least YAs to here, which we're not doing here, because there is no other way for this WR to be in a way that is represented at the end of the string without breaking this form, then this language cannot be regular. Derived our contradiction. Questions on that?
Would it be also valid if you just picked A to the n 4 times over, because technically they are
Reversed.
reversed.
Yeah. You could do that, but then it would be possible for me to add some number of A's to that with a particular value of I, such that the result is in the language. It's just a different length A, a different length W.
Right, okay.
So you could do that, but it would lead you to problems.
Some that would be useful.
Correct. How do we feel about regular pumping lemmas at this point? Last I checked in with people, we were starting to, at least we were saying that we were somewhere between starting to go from mid up to this makes sense. After doing some homework with it and studying a bit for an exam, we feel like we're ready to do this on an exam.
Regular old pumping lemma?
Regular pumping lemma.
Regular one? I feel pretty good about it, yeah.
Right? If we're still in kind of the mid area, that's will be what good office hours are for. The issue with office hours today is I'm going to have to delay them because we have a faculty candidate for cyber and I have to go to research talks, teaching talks, and lunch with that candidate. So I will have a little bit more availability after about 12:30. So between 12:30 and when I teach at 3 would be the best time to come find me for any questions that you have today. I also wanted to make an announcement before class started. That's just how scatterbrained I am today. So we have upcoming on the 15th, the ICPC programming competition. For those of you who have heard of that before, it's great. For those of you who haven't heard of it before, it's also great. It's a programming competition that is hosted by ACM, the Associated Computing Machinery. And this is an excellent opportunity to put something on your resume and show the skills that you have acquired throughout the time that you are here. Basically, you'll be given a packet of about 14 programming problems and 5 hours to solve them in a group of 3. And depending on how you do, this is something that's hosted locally. There are 6 Gonzaga teams signed up. I think something like 8 Whitworth teams signed up. And we have spot for about 6 teams of 3 if we can find that many interested people to go do it. Eastern will cover the cost for all of that. For your ACM membership, for the team registration fee, you get a t-shirt out of it in exchange for your entire Saturday. But
where do you
it's worth it. It's at Whitworth.
Oh,
Yeah, there's usually a local site here because driving over to the west side for this is annoying, but the contest happens across the entire Pacific time zone at the same time. So there are sites in all over Washington, Oregon, California at the same time. And it's hosted at different times throughout the day, at the different time zones throughout the world. And so it's a regional competition, and if you place in the regional competition, you go to nationals and the worlds, which would be pretty exciting. We had a team almost place last year. Place locally, they didn't place within the time zone region to be able to go to nationals, but within the 8 teams, 6 teams, and 3 teams we had there last year, so we'll almost place in the top 3. It'd be really cool if we had some teams there this year, a little bit to fill up the 6 slots. So if you're interested in that, it's a great resume item. People know what the ICPC programming competition is out in industry.
Where do we sign?
It's just for the moment, send me an email that you're interested, and then I can get people together and say, either make a Discord or something that says, here are all the interested people, let's form teams. Right now, it's kind of just posted as an announcement in the CS Discord, but as the ACM coordinator here, I can handle interest and try to make that happen. If you want to see what the kinds of problems are like, the site with all of the historical problems is Caddis. And so you're just turning input into output. What makes this different from something like LeetCode? LeetCode will give you a topic, something like, let's have you study linked lists. Here are a bunch of linked list problems. Study recursion, here are a bunch of recursion problems. ICPC gives you a problem. It does not tell you what you are practicing to solve it, what algorithms you need to solve it, but it gives you a limit on the CPU time and memory that you have available. So just because you can solve the problem doesn't mean that it will be correct. It has to be solved within the time limit with the memory limit as well. So you must know your algorithms well to be able to optimize the solution to the constraints of the problem, which is really cool.
And that's on the 15th?
Yep.
Okay.
Saturday, November 15th. Assuming we have at least one team, I will dedicate my Saturday to being your coach. But I would love to have at least one team, because otherwise I will wish that I were at Whitworth doing that with my Saturday. It's actually a really nice opportunity for me to connect with the local CS professors, the local scene, in ways that I don't otherwise normally get to do. So it is absolutely worth my time to go prepare and do and provide that experience for.
And it's any undergrad student?
Yep.
Is eligible?
Any undergrad student, there's no limit on the number of times you can do it, as long as you are an undergrad student or a graduate student that meets very specific criteria, like you cannot be 21 yet. You can't have a total of more than this many credits as a grad student, et cetera. But for undergrads, there's no. Highly recommend, especially because it's free. It wouldn't normally be free, but I'm begging the dean for money and getting money from the dean. So we will have money. Don't make me beg the dean for something and then she's like, just kidding, we didn't have enough student interest. Thanks to me with that.
Has that been an issue in the past, not having enough student interest?
Last year we had one team leave sick. So we only had 2 teams there, and one of the teams was a grad student and a couple of upper division undergrads, and then we had another lower division undergrad team. So I would love to see just more, because there are more spots. I would love to see more teams and have Eastern, as the biggest school in the area, have a presence that matches the other 2 universities in the area. It's kind of embarrassing to be, we have the most students with the fewest teams. Also, rah, beat Gonzaga.
You could try sending an email to the CS student list.
Yeah, I definitely need to spread the word a bit better. It works best for upper division undergrads, those who are taking something like compilers. This is why I'm telling this to you, or software engineering that I'm also teaching in. But if I could shout over to algorithms, I don't know if algorithms is meeting today. I could shout over there, but. Any other questions on that? Sorry, it'll take 10 minutes of.
No other questions?
Yeah, what else can we go over?
I would
Yeah.
like to go over maybe a problem where you have a grammar in Greibach form and you're trying to make a DPDA or a
NPDA.
NPDA.
Yeah,
Trying to, yeah, an NPDA out of it. That'd be fantastic. We could use, I mean, there were a couple of problems on the homework. Although I think, if I remember correctly, so it's the first simple problem on the homework. I don't think that was Greibach. And then the second problem,
yes,
the second problem's a bit more complicated, but
doesn't matter to me.
if we have time, okay, yeah, so the grammar, S goes to little a, big B. Or little a, big A, big A. Well, there were two big B's on the first one, yeah. And then A goes to little a, big B, or little b. And then the last one is big B goes to little b, big B, or big A.
All right, I like it. Let's make an NPDA for this. So how we're gonna start, we have an initial state. We'll call that Q0. The very first thing we need to do is push on the start non-terminal. Because every grammar has to evaluate the start non-terminal into something. And we don't want to loop that process, so this needs to go to a new state. So when we read nothing from the string, the very first transition is going to say we read nothing from the string. When we pop the bottom of stack character, because that's what has to be on the stack when we start, we're going to push on the start non-terminal on top of that bottom of stack character. Then we need our very big middle state that's going to handle all of these transitions. Because that's how we roll with NPDAs. So self-edge, and I'm just gonna write a bunch of transitions down here that represent every single one of these. In general, all you have to think about is the associated form, where we're gonna break each of these down into the character that is read, which is the lowercase character, all of the non-terminals that follow, and the non-terminal on the left. So these are our three components of any particular edge transition on an NPDA. So this says when we read an A from the input, what do we expect to be on the stack in order to be able to do this?
Yes.
The S, what's on the left? We're gonna be replacing this by reading this with that. It's kind of an object transformation. On an A, we pop the S off the stack and we push everything that is left. We've turned that S into an ABB by reading an A. And it's exactly the same for every other middle transition. There's not too much difficulty with this. It's just reading the grammar and converting it to the associated form. So we can also read an A, pop an S, and push on an AA. We can read an A, pop an A, and push a BB. We can read an A, read a B, read a B, pop nothing. Or pop an A, push nothing. We can read a B, pop a B, push a BB. We can read nothing, pop a B, push an A. Do we see how each of these transitions maps to the associated grammar production? I just went in order. The S, the S, the A, the B, the B. Character that you read is the lowercase letter. If there is no lowercase letter, replace it with a lambda. The next symbol is the left-hand non-terminal, the left side of the production. The right-hand side is every non-terminal on the right-hand side of that production.
In that sense, it seems kind of like follow the stack trace with
Yeah.
the non-terminals as the functions.
Yep. That's exactly how that works.
I don't know, I think I'm mixing up the definition, but isn't regular form supposed to have? Non-terminal to at least one terminal, followed by zero or more?
Yeah, it should be. So is this? This is supposed to be, so we have to convert this into GNF first, and this isn't in GNF first because of this reason. So this rule wouldn't be allowed. What's actually fun is it actually still works in a non-deterministic PDA. If we needed a deterministic PDA, now we have ambiguity. Well, we actually had ambiguity before with the A and the S. But if we wanted this to be in GNF first, then this A would have to pull down every definition from here. And this should technically be the ABB or B. In which case, we'd replace this with read an A, pop a B, push a BB, which is distinct from that, and read a B, pop a B, push note.
So that, would that be valid then?
Yes, this is exactly the same grammar.
Because that's how I had it set up then. Because originally I did do the.
Yeah,
the
but
A.
recognizing that it wasn't in
Yeah.
GNF. Yeah. As long as it's in some form like that, then there is something you can do. But yeah, we would want to read a character for sure each time. We don't have to. The lambda does work with non-determinism, but this does reduce the amount of non-determinism in the associated grammar and PDA. We just know that we do all of this, and if the string is accepted, what we need to do is transition to an accepting Q2. But that transition has to be with the bottom of stack character. We have to have removed this S somehow. So that's going to end up in one of those two transitions, but we want to read nothing, pop the bottom of stack character and push it back on, or not. Again, depending on whether you care about the bottom of stack character being there for acceptance or not. And that finishes it off. Anything I can clarify? Does that process make sense? Do we see how this answers the problem of this grammar, where if there's a string that's in the language accepted by the grammar, now there is a way to basically go through every step of that grammar, which is one step in this self edge on Q1 before we empty the stack through doing this, get rid of the S that was pushed on at the beginning. That means that we were able to resolve that S into a sequence of terminals, not just non-terminals, because that's what's on the stack. In order to have an empty stack, you have to have evaluated every non-terminal down into its associated terminal forms. And then we end up going over to acceptance when that is done. And only if we are at the end of the string do we accept that. There will be times where maybe the stack is empty, but we can't go over there because we're not at the end of the string. Or if we can, we just won't accept. Seems like no other questions on it? Level of confidence for this kind of problem? Okay, I see why there were no questions. Everyone's confident. Hey, what's the next question that people might have? Yeah,
This is 3J's, how do context-free grammars model language syntax? How do they fail to model semantics?
yeah, so context-free grammars like this model, we had the examples in class of things like scope. So they're able to model mathematical expression logic. They're able to model the curly braces of scope. They're able to model stacks. So the call stack, the ability to, just basically changing scope and allowing for recursion. And all of that is necessary to model any modern programming language syntax, because that is the basis of which modern programming languages are written. So I think the ideas you want to tie yourself to for syntax are mathematical expressions and scope, and how you can do that. failing to model syntax, though. So this was the example where we said something like, is it valid, sorry, semantics, is it valid syntactically to do something like, I think this was directly pulled off a slide. Is this syntactically correct
Yes.
in Java? The answer is yes, it is. It's just that it has no meaning. This does not map to something that we can actually do, but it has a type, a legal variable name, an assignment operator, and a valid something that evaluates to an expression. So we have variable equals expression with a legal type and a legal variable name and a terminator. So there's nothing syntactically that we can attach ourselves to that says this won't work. We have to look at the semantics that says, what I expect when I evaluate this is a character. What I expect when I evaluate this is a float or a double. And I cannot assign, it's a semantic rule that I can't assign a float to a character variable. Note that I could create a grammar for this, but I could not easily create a grammar that would say and actually analyze why this wouldn't work. There needs to be some kind of semantic tree analysis of the kinds of variables that we can assign to the other kinds of variables, or the kinds of expressions we can assign to types of variables.
Would another example of syntax versus semantics be supposing you had like a complicated arithmetic expression and it was parsed correctly and it was totally accurate and valid, but in terms of what the grammar can do, the grammar can't compute the result, right? Like you need to actually like run the program.
Sure.
Is that like another example of the difference between it's syntactically analyzed, but your grammar can't actually like tell you like, okay, so what's the result of adding and multiplying these numbers?
Yeah, I mean, that would possibly also be the case if we try to, so there's interpretation that's needed in Java, for instance, to be able to handle something like the compiler can do this for us in Java because of a particular interpretation. This is concatenation. And it's recognized as concatenation. You run this in Java, you'll get hello free. You try to do this in C++ and you'll get a compiler error. So the compiler is doing the interpretation, not the actual language itself, not the actual grammar itself. So yes, you could have the evaluation of an expression that the compiler can't interpret because either you have to have a rule for that interpretation or break because there's either ambiguity or you just don't want to support that. And there are arguments either way. And you would find if we actually had a programming languages course that the more languages you look at, the more you start to understand the design decisions that go into those languages and why they make those associated decisions. And that allows you to pick and choose between the languages based on what you want out of the language, what you want out of your program. There will be better decisions than others and worse decisions than others based on that idea. What kind of interpretation do you want for something like this? Do you even want to support it in your application? If you want to support it, you should pick a language that supports it underneath the hood. Otherwise, you're writing the part of the compiler that does what you want. Or maybe just writing a new compiler, because there can be multiple compilers for a particular language. There's nothing that says that, given that we have the language Java, that only one compiler can exist. It's just a translation.
I bet you could do it in C++ with templates and macros.
Yes, you can. It's not natively supported, but C++ is very nice in that it makes it easy for you to design things like that. You can design the functionality that you want. You just have to know what you're doing it of. So yes, that's a very good question on syntax versus semantics and how syntax links to grammar and how semantics really ends up leading to parse tree. a different kind of parse tree than the grammar parse tree that we talked about. What else can I answer? Sure.
Yeah, I was kind of saying, it's risky context.
Okay. So we only, for this exam, only have the ability to prove that something is context-free. We don't have to worry about proving something is not context-free. But if we wanted to be able to say, show that this particular language is context-free, how would we do that? What options do we have?
You can make a,
Should let it be more with the,
NPDA.
NPDA, yep,
I was gonna say, a PDA, wouldn't an NPDA still say, if we can construct an NPDA for it, does that mean that it is?
yes.
Oh, okay, I thought there was.
There is that other language class, the DPDA class, but it's a subset of it. So I would focus on NPDAs because there will be some languages that are context-free that can't be modeled by a DPDA. And NPDAs are just easier in general than DPDAs to construct, so just throw that out the window unless the problem is specifically asking for a DPDA. Attach yourselves to an NPDA and just don't worry about the deterministic restriction on NPDAs or something that is context-free. What's the other option though?
If you made an NFA for it, right? Because even though that's like an even simpler class, that's
Yes,
regular,
You
like
could.
it's still inside the
You could.
context space. Okay.
yes.
If you could, you could.
Yeah, I wouldn't try to force yourself to make it, but if you see, I can recognize this with an NFA. Then. That would work. That said, that would be an interesting problem for me to pick for an exam. Prove that this is context-free and not make you use the context-free tools for it, but make you. Allow you to be able to use a tool from a prior exam.
Okay, another question. And I think I know the answer, but so also in the way the pumping lemmas work, if you prove something is not regular using the regular pumping lemma, that doesn't necessarily mean it's context free. It could
Correct.
be outside of
Yeah,
context.
it's just saying it's outside of regular.
Okay,
So we said we wanted to get an example of proving that something is context-free. We have similar to a homework problem that we can look up, one of the non-assigned problems or something from a homework that someone would like to go over.
Others.
We're looking for some kind of language definition where we either want to make a grammar or an NPDA.
Find context-free grammars from following languages. View 8, it's the number of A's and W's equal to the number of B's and W plus 2.
So the number of A's in W plus, what was it? Number of A's in W
Is equal to the number of B's and W. Plus 2.
Fun, okay. So first thing I will ask you is, are there more A's or B's in the string?
or A.
There are more A's, yes. So again, this will show up on some exam at some point in this course. There will be a question like this, where the most common mistake that I see is that people flip the associated results. So if you see something with an equals in it with something on either side, ask yourself that very basic question. I should say W such that, referring to a W that has no definition. All right, so we're making we want to go the grammar route or the NPDA route, which makes the most sense? Intuitively,
I feel like the grammar would be the easiest to construct right off the bat, but
Okay.
I mean, I thought the NPDA was what we wanted to make.
the question asks for a grammar,
Oh, does
but if I'm reinterpreting the question, as show that this language is context free, then you would have either option.
I mean, if it's asking for a grammar, you can just have S goes to A, S, and B, or it can go to AA.
So we need the ability to produce A's or B's in any order where we just care about the associated number. So we need some ability to produce these two A's that are the two more A's than B's that we have.
I missed that too. I feel like the NPDA might be easier actually.
Honestly, I think the grammar might be itself.
There's like a pretty standard form for being able to just make a W with like A star, B star, right? It's like
Mhm.
ASB, BSA. And it's in like a bunch of them.
Yeah,
ASB or BSA or A.
And then S would just be.
So
AA.
what I immediately want to do for this is produce the two A's. Allow for anything before, in the middle, or after. And then define what that anything can be. So we need the ability to produce any number of A's, any number of B's. In any order.
A like recursive by
But
itself.
we do need to keep them the same. So we're right that we need the ability to make pairs of A's and B's. But they could be in any order. How do we do that? I like the ASB or BSA. This allows for there to be an A followed by a B or a B followed by an A and you recurse in the middle.
Yeah.
What happens if the associated string starts with an A and ends with an A but has more B's inside of it?
So we could allow A to be empty, right? Or
Yes, it does need the ability to be empty, so we could. But you can imagine that what comes before this first A is something like A, B, 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 A. Where the number of A's are the same as the number of B's, but if we're going to recurse in the middle, the first character and the last character are both A's. What we're gonna wanna do is be able to create a loop. Something that says, if we do this, then we need to do this inside of it. How could we construct that?
oh, I guess with a new non-terminal. Like it could be well, no, I guess not new, a new case for A.
What if we have A go to AA, because then we don't mess with the number of A's and B's, they're still relative to each other, but then we can now.
Interesting.
Reflect it. I don't know if this will solve the entire problem, but it will solve that.
Okay. So it allows us to say, from this AA, well, because of this recursion, we can produce an arbitrary number of them. Can we produce this entire string now from saying AA here?
Yeah, because you
Yeah.
can just, now you have two A's. And the first A is the first four characters, the second A is the second four characters.
And this is now ends with an AB and an AB inside of it, so we can solve that with this and this.
Yep.
This can be solved with this and this.
Yep.
What if we had A, B, 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 A, B, A, B? How do we solve that one?
We just do
We
it.
can. The question is just how.
We can just do it again, because then now we have three A's and we can just make
Yes.
them
So A goes to AA. This first A is going to split into two A's. And now we evaluate the first two A's to be what they were before. And the third A becomes. Do we have the ability to represent BAAB?
By splitting it again.
Yeah.
Yeah, it does have to split again. Because we have no ability to produce a beginning A and an end B. But what we could do,
What about we have the A as the AA, then the first one be B as A. Oh, wait, no.
what I would do is recognize that this A and this B map to that. So now internally we have this, but because we see an A and an A, now we have to split this into AA. So we need some middle point, but because this is non-deterministic, we can figure out where that middle point is with non-determinism. Where we're gonna split this to where we have an equal number of A's and B's somewhere in part of this. So here we have an equal number of A's and B's. So this AB can be represented by ASB and lambda. So let's actually make this tree. I'm actually gonna fully write out this tree because I think there's value in seeing that. But we start with an A. That A becomes ASB. That S becomes an A. I'm just gonna start writing. This should be A, shouldn't it? Not S. Yeah. That's my bad.
Yeah, that's not what I realized.
Yeah. Obvious in hindsight. So this A, now I'm going to split into, because we have a starts and ends with an A, we can't immediately handle that, so we need this to go to an AA. So we need some middle point here, where this A is going to become AB that goes to lambda. This A is going to be this B to this A, which we can recognize as B A. So that gets rid of that character and that character. Inside of that, there's a B and an A, so this A should go to B A. That gets rid of that B and that A. Then we have a B and a B, so this A should split into AA. Where the first one is BA, so this is BA, where this goes to lambda. And the second one is AAB, where this goes to lambda. And now if we do a depth first search in this tree, we reconstruct that string. So yes, I completely agree that the AA at the end does solve this. And we choose this rule if we see first character A, last character B. This rule, first character B, last character A. This rule if first character A, last character A, first character B, last character B. Of course, on a single pass left to right through this, we would not be able to determine which one to use. So we would have to use non-determinism to do it. But because this maps to non-deterministic pushdown automata, we allow for that non-determinism. We can use our multi-parallel brains to analyze what comes at the end and know that based on the construction of this, what it's actually mapping to is what's on the end. But again, there would be no way to know that for sure with a program unless we use non-determinism. Or could analyze from the back to front with the Turing machine. How are we doing? Does that make sense? We have AA, BBB, B, A, B, B. It's the exact string. Cool. No mistakes. Looks like a second grader wrote it, but. Yeah.
Would this work if it was like NBW plus one, so you could have an odd number of total characters?
That becomes much harder, doesn't it? So you would have to have that A somewhere. So I think it's not too bad. You just do that instead.
Oh, yeah.
Yeah, so the reason this answers that is we just needed the ability to do anything. Recognize any number of A's and B's that are the same. And then it was this structure that allowed for the +2. If we have that A capital A, then these are the 2 extra A's, and every other A has to be some equal number of A's and B's in some capacity. But those A's and B's can come anywhere before the first A, after the last A, etc. So we know that because we can map the string to that structure that it happened. Yeah.
If we have a CYK problem on the home, on the exam, how in detail do you want us to go for each string?
So hints for this, if I'm designing a CYK problem, it's going to have to be a very small one in nature, unless it is the only question I ask you on the exam. And since there is a programming assignment for it, and you've done it on your homework, if it does show up on the exam, it is going to be a very small CYK problem. So because of that, I do still need to see that you know what you are doing with that, but do at most the amount of work of 1 per row. So N11 show that work, N12 show that work, N13 show that work. I'm probably not making anything longer than that and throwing it on an exam because I want you to answer other questions. And not be so crunched for time that you hate me. Question?
All the questions from the exam could be how they're forming on the homework, or they're gonna be the short answer.
There'll be some of each. So some where you're actually solving problems and some where you're maybe more like Devin's question about syntax and semantics, or kind of some of the underlying ideas of that we've talked about in class.
When you said show the work for the CYK, what does that, what is the extent that you want? Just show what the character is for an IJ.
Yeah, just for one IJ for each row.
Oh,
And then if you filled in the rest, I would say you applied that same idea. And even if it's in Scratch at that point for seeing it, then I want to see the Scratch, but it doesn't have to be explained in quite that level of you know what you're doing, etc. Yeah, don't anticipate there being a string longer than 3. No real limit to the size of the grammar, but I'm not going to ask you to determine whether a string of longer than 3 is. In the language. For those who have started CYK, how's that going? Sounds like at least one person started CYK. I'll call that a win.
I've got other fish to fry until Sunday, so.
at this point though, I haven't really gotten to the point of implementing CYK, it's just a matter of reading the file, parsing.
Sure.
Parts and such.
Makes sense. There's certainly, I designed it exactly like an ICPC problem, actually. So if you are enjoying kind of that input-output format where it's just a bunch of numbers and you're expecting a bunch of numbers and maybe a little bit of text, that's very much in the style of actual programming competition problems. What other questions do we have? We have like 1 minute. Few questions is either a very good thing or a very bad thing.
So you're not going to have us converting between, for example, C and F, G and F, vice versa.
You know, you didn't really have any homework problems. For, if there needed to be something in CNF, then that would be like a regular grammar into CNF, sure, but not CNF to GNF or GNF to CNF. And we really only talked about converting into CNF, so I don't think it'd be reasonable of me to throw a convert into GNF on the exam. I think people could do it, because it's reasonably intuitive, but we also didn't really cover it. If it's not on the study guide, I'm not gonna throw that kind of question on the exam. The study guide is kind of my promise of questions are going to come from this bank of ideas. It might not be exactly how the question is worded on the study guide, but it gives you an idea, and that idea is fair game to show up on the exam in some capacity. When I write exams question by question, they come from elements of the study guide. I say, that's a good element that I think is really important for me to test. How can I challenge you? How can I challenge your understanding of this idea? All right. I will see you tomorrow for that, and then you will be free Halloween weekend unless you're in software engineering. Pray for Craig. Kids come to your house, trick or treat, go away, I'm working at home. Enjoy your childhood while it lasts.
My mother has a really steep driveway and then like shared approval. Yeah, I was telling her that you can buy full size candy bars for the kids that are like willing to do it. She never goes for it.
Maybe I could have some Gatorade or something like that. There you go.